Hello friends, good evening all of you. So again today's session we are going to say about the same concept graph theory. So already I told you that graph theory we have it's a number of this one sessions number of it's a vast one. Okay, we have lots of concept actually. So today we are going to see related PYQs, graph theory related. For example, we can take it an internal node based one and just some of the few PYQ questions. Then we can see about planner, non-planner, and this is depends on the only PYQs. Today we are going to see. Next class we are going to see full and full is a important thing. It's the next one, LPP model and simplex method and dual simplex method and very important transportation problems. And the next one's assignment problems. These are the things we are going to see next classes. So one class, concept will come. For example, first concept LPP means it will take full and full class actually. It's a half an hour, one subject, one class question only. It will take it's a half an hour. Like this, it will come. It's a huge concept actually. Uh, just how much it's possible, we can see the PYQs, one or two questions or two or three questions like this. Other questions again, I'll tell you after this concept, just you can practice everything. I'll put in the playlist also after completing of discrete mathematics full and full. You can see every videos. If you have any doubts, actually we are going to conduct live session from not coming this week, next from next Sunday onwards we are going to conduct every Sundays. Okay, so whatever you ask is just you have completed, just we can go through. And PYQs, we have lots of PYQs, at least minimum we have to cover actually 5 years of question paper. That is my target actually. Okay, apart from that syllabus, I am telling you. So September month we are going to write it a set exam, yes. So December month we are going to write net exam. So at least September we are going to cover the half of the portion. Really, I'll complete even set exam, previous year set exam also. I'll include this one. Okay. So try to focus and just again I'll tell you. You can, if you have any doubts regarding any classes, you can just watch full videos and post in the comment box or join in the WhatsApp group and you can ask me. Okay, now we can move on to the today's class. First one, just this type of question actually, they will give some questions, five questions like the comprehension based questions. They will give some one graph and they will ask five questions. Like this DBMS, they will ask the one table and they will ask us five types of queries. The algebra queries and nowadays TOC also they are asking five questions like this maybe. So if this type of questions, if you know well, really sure you will get high marks. Okay, this type of questions actually five questions means minimum three questions. Sure, you will get easy question only. While seeing itself, you can understand actually. This is this one method actually. So two questions only. It will take little time. That's all. But this is very easy question. While seeing itself, we can understand. Just the only one time we got this PYQ actually. You can see this is the graph. So what is the cyclomatic complexity of flow graph G? So now here first one cyclomatic complexity. What is region cyclomatic complexity? These are the same thing only. And one more name also is there. I'll tell you. Again, I'll tell you. Region is the same and cyclomatic complexity also the same only. Region already we have calculated one more one sum actually. It's the last video or the before that video. So what is the region formula? Just minus vertices plus 2, I think. Okay, so here how many nodes are there? Edges means one more name, nodes only. So we can say edges are nodes. So 1, 2, 3, 4, 5, 6, 7, 8, 9 edges. Okay, how many? Sorry, this is I'm saying this is 9 vertices. What is the edge actually? Edge you can calculate. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 edges. So 11 minus 9 plus 2. So what is the value? 2 plus 2 is the 4. This is the one method to calculate region or cyclomatic complexity. Okay. Another method actually we can put in the direct number of inner cycles plus one outer cycle. What is the number of inner cycle? 1, 2, 3 and 1. Our last one outer cycle will be there. That is called this one totally 4. So again I have given actually this is the method 1. This is the method 2. For your reference I have given regions equal to closed cycle plus outer cycle. This is one of the concept. So 3 plus 1 4. Method to number of edges what? 11. Number of nodes means vertices. What? It's a 9. So edges minus nodes plus 2. This is a formula. I told you edges minus vertices plus 2. That's all. So 11 minus 9 plus 2 is equal to 4. This is the method to find out this one. Okay. Next one. How many nodes are there in the longest independent path? So we have to find out which one is longest independent path. So you can see 1, 2, 3, 4, 5, 6, 7, total 7. But here they're asking how many nodes. How many nodes? Only two paths we can take. One this path or 6 to 8 we can take. Anything. Anyway we can take, we will get the same thing. But we have to calculate the node, not edges. So 1, 2, 3, 4, 5, 6, again this one 7, again 8. So longest this one 8. Okay. So next one, how many predicate nodes are there and what are their names? A predicate node means nothing but actually from one vertex there it is going two ways. Two ways will be there. This it will going 11 and it is coming 2 comma 3. So this is one is a one predicate node. Next one you can take 2 comma 3. So it's going to 6 and 4 comma 5 also. So this is also one predicate node. This is 1, this is 2. Next one 6 you can take to it's going 7 and it's going 8. So this is also predicate node. So totally 3 only. 7 it's going only one place. 8 one path only. One way only. So totally I have 1, 2 comma 3, 6. So totally 3. So here what is the question? How many predicates node? Okay, 3 are there and what are their names? It's asking. So 1 we should write 2 comma 3 join together one node actually. So 2 comma 3 join together bracket one node and 6. That is called predicate nodes. And how many nodes? The same thing in the flow graph. Totally how many nodes? It's calculating 9. That's all. Node only just vertices. Okay. So this is another exam, another types of question. A 5 array entry and every internal node has exactly 5 children. So the number of left nodes in search a tree with 8 internal nodes will be what? So internal nodes L is the complete n array tree. The formula L equal to n minus 1 into I plus 1. So already I told you every class I'm telling the same thing. After the completion of every unit, sure I will forward as a um, word file formula files in WhatsApp group. Okay, that's why I told you to join in the WhatsApp group. We have two groups. Any group you can join. Even just I have given in the WhatsApp link here. There also you can join. Sure, you will get every formulas. For example, after discrete mathematics, what are the formulas are there? Separate word file I'll send you. Apart from that, we have in graph itself we have digital algorithm and so many greedy up. These are the things that match the following. They will ask many questions. So I have created some match the following separate file actually. It will be very easy to understand actually. While seeing the calculation itself, if you are seeing what match the following and these are the formulas means really it's very difficult. Okay. So that's exam purpose nodes I have created. So these are the notes whatever I am forwarding. These are the notes. This is the exam purpose note. Even exam before the day also you can revise. You have to memorize that one. That's the thing. Okay. Now what's the thing they have given? Actually internal node has exactly n 5 children. So n is equal to 5. 5 minus 1. What is the I in 8 internal nodes? So into 8 plus 1. Just you can multiply 5 into 8, 5 into 8, 40, minus 1 into 8, 8, plus 1. What is 40 minus 8? 32. 32 plus 1, 33. So this 33 will be the number of this one. So this is the method to calculate. This is easy only. Sometimes L they will ask you, sometimes N they will ask, sometimes internal notes they will ask. So depends on that we have to work out. You can see here, this is the same question. L they have given, I they have given. What is the value of N they are asking? Okay, so the same thing, L equal to N minus 1 into I plus 1. It's the same concept actually. Now N we don't know. L what is the value? L is the 41 the value. Now N minus 1 you can put the same thing into I is a 10 value I plus 1. Okay. Now what is the N into 10? 10N minus 1 into 10, 10 plus 1. Here 41. So this 41 you can take here, this 10 you can bring it here, plus 10 it will come, plus 10. So 10n mine plus 1. Now what is the value? Just a step by step I am telling, that's all, where nothing is, it's the same, easy we can do. So 41 plus this is 10, 51. Yes, 51, 51, just we can make it here, 10n we can keep it here. 51 minus 1, this one minus 1, what? 50. So n equal to 50 by 10 equal to 5. So n is the 5 value, that's all. So everywhere I have given calculation there itself, just to your understanding purpose I am writing and telling, that's all. Because every calculation based one we have to know, understand properly. Again I'll tell you, if you want clearly, just while seeing the video itself you can work out and check it yourself. And one more thing, after completion of discrete mathematics, even any units, first class itself I know, just I told you, uh, just after completion of every unit you can check your status. I'll post very often even previous year question papers also. Just to take any one question paper and you can go through everything. How many seconds it's going to take to understand the concept. While seeing itself, it's a discrete mathematics. It's easy or not. It is possible to work out or not. Just to see your status after you practice little bit. Okay, so it's still how much we have to practice. So unit wise you can do your status. It will be very good actually while improve yourself. Actually, discrete mathematics, every sums, if you'll practice 4 to 5 times, automatically you'll reduce your time management. Really, it will be very good actually. We need a practice for discrete mathematics. Okay, this is very simple actually. K22 means this is a base value. K22 means you can take it as a bipartite graph. Bipartite graph. This is K4 means complete graph. Okay. So now first complete graph, what is the formula? Means number of different spanning tree to find out. This is Kn equal to n power n minus 2. The n power n minus 2 is a formula. And number of different spanning tree bipartite means m power n minus 1 into n power m minus 1. This is the formula. Just we are applying, that's all. We got 16 comma 4. Okay. Okay, next one. This is one of the important thing. A click is a simple undirected graph, a complete subgraph that does not contain any larger. Actually, click, how many clicks we need to find out. That's all this diagram, nothing. Suppose this is the output actually. This is the output. This is input. Okay, input they have given actually. This diagram they have given. Click means we need to find out separate parts actually. This is first one. This is second part. First part, second part. This is third part. This is fourth part. This is fourth part. Okay. Now this is full and full joined together one part actually, fifth part, because they didn't give any vertices here. Here they have given G. Here they didn't give. So totally it will take full and full one click actually. So totally 5 example. So that's why separately it has drawn this diagram. That's all. But basically these are the things we need to find out. Click means. Next one, this is a coloring graph. So the two distinct set of vertices which make graph bipartite are, next you can see coloring graph. We have to color it. First one, I am putting here red color. If you'll put red color here means adjacent matrix, adjacent vertices, it has to be in the different color. Okay, so this is also adjacent, this is also adjacent, this is also adjacent. So I am putting green color here. So here also green color, here also green color. So here green means here it has to come red. Here green means it has to come red. Okay. Here green means here red it has to come. Here red means here it has to come green. Here green means here what we can write red. And you can check here red means this is green. This is also adjacent green. This is also adjacent green. So here only two colors it's enough. Sometimes suppose diagram if they will give directly here like this means it won't it's not enough two colors. We have to make it sometimes three colors. Okay. Now you can see the color just red color and blue color we have just. So you can see this diagram. First one V1 red color, V6, V7, V4. So V1, V4, V6, V7 this is a separate color, one color, and V2, V3, V5, V8 is a separate blue colors. That's all. Like this we have to make it as a coloring graph. And chromatic number of following graph, that's also coloring only. How many colors we need for this diagram actually they are saying. For example, I'll say here red color. I'll say here I'll take blue color. Here I will take for example here red is there. Here blue is there. I can't put red here because red is adjacent here. We have to make it some other color. Blue also I can't put because here blue is there. I have to make it some other color here. Is it clear? I think if you have any doubts, you can ask in the comment box. Adjacent vertices, it has to be other colors. So no way I have to make it third color. That is called I am making green color. Now here you can see this is green means here I can make it blue. Here blue means here I can make it here red is there. So here red is there. Here blue is there. Here blue is coming. So automatically I can take green also I can't put here. So green here it's coming. So this red I can make red here. It will be best. So I can make blue here. So this color and this red no problem. It's not adjacent. This is not a this one. So I can make it blue here. So here blue color is there. Here red color is there. Here blue color is there means automatically it will be a green color. So like this we can make it a small diagram only, but it's different a variety of designs. So automatically it's making three colors we need actually. So that is called three colors is a chromatic numbers actually we have to do. And let G be a connected graph with partitions, so x equal to this y. So like this we have two vertices one side and two side means this is actually bipartite graph. And arranging the following graph on the basis of number of edges increasing order for n greater than 3. Okay, so they have given Kn means complete graph, Cn means cycle graph. They have only given this is the question actually. Wn means wheel graph, Knn means is a complete bipartite graph, Qn means n cubes graph. So what is the order we have to make it? Just I have written here you can see first cycle graph in Cn n edges. Okay, so number of edges for each graph. Just wheel graph means 2n is the two edges. And complete graph means n into n minus 1 divided by 2 edges. And complete bipartite graph means n squared edges. N cube graph means this is called n dot 2 power n minus 1 edges. These are the formulas we need to understand and we need to memorize sometimes. But this is the first question, different types of graph there. They asked us the chronological orders actually ascending orders. Actually, this is the first, maybe last set. I think Jan or within two sets only they asked. They asked actually. Okay, so this is the order. This is the order. So this is the answer for this one. Okay, actually, for discrete mathematics, I told you first itself in the paper two, we have to work out minimum 5 sets of question papers. Minimum, I am saying, not maximum. Maximum 10 sets question papers, 5 years question paper. minimum 5 sets of question paper per year. We will get 2 question papers. But paper one, it's not like that. Paper one, actually, we can take 3 sets of question paper. It's more than enough to find out all things. 3 sets means how we are saying, for example, last exam, what we have done, maybe June 23, June 26, Jan 26, uh, and June 25. This 3 sets of question papers, full sets we have to take it. Full sets means what? For example, Jan 2026 means there we will get lots of departments. Tamil department, English department, Maths department, computer science, economics, like this. Like we have lots of education, lots of departments. Every question paper different, but it will repeat it also actually first paper. But sure, 10 types of question paper we will get. So 3 sets if we'll do fine, complete go through. Sure, you will crack that paper one. Actually, this is the method to only every competitive exams PYQ. It's an important thing we have to practice. Okay, last thing, planner only we can see fast. Planner, two graph they have given. Planner, already I told you types of graph. Just I have taken note. There itself I told you what is planner. Planner means edges is not allowed to intersect actually. That is called planner. For example, you can see here that is intersecting these edges. It's not allowed. Here intersecting these edges, it's not allowed. Here intersecting these edges is not allowed. So we have to try to make as a planner if it is possible, whether we need to find out planner or not. You can see this diagram I am going to write now. This is the diagram. So here, this line I will write. I will draw here. This line I'll draw here. This, instead of this line, I am going to write it's a this side. So automatically they are just not intersecting here. So automatically this is a planner. So this is a first planner. Okay. Second one, this diagram only little bit we have to think about this. So this is the model we have to do. So again, proper connection it must be there. So this is the model. We can make it the same concept. Will get the same diagram. This is also a planner actually. So both are planners. So intersecting edges are not allowed in the planner. That we must check. So here you can see one of the other questions. Which one of the following is not planner? Which one is not planner? They are asking. First one, you can take G1 diagram. I will take one. I will draw this here. This diagram. Okay. So this line I'll draw here. Okay. Instead of this line, I will draw here. Now this line I have to make no. This, if I'll do this one also, I'm getting intersecting. Even I'll make this time this here, from here to here also I'm getting intersecting. Here to here also it's not possible. So G1 is a not planner. This is the answer. So other diagram also we can see. Now G2 we can see. See, this is the diagram. Yes. Now I will write this line and this line. And this, in this line, instead of that I am going to draw here. That's how this is a planner. Now we can make it. So this is the diagram. I'll make this one and I'll write this one. This one and this one I'm writing. Instead of this one I'm going to draw. This is the method. So this is also a planner. And this one you can take it. First one, this is the method. Okay. So this and this I'm going to draw here. Now this one I will make here this side, and this one I'll make, oh sorry, first this one and this one. Sorry, first one, this one and this one. Any other terms I have to take. It's not coming answer. So first I'll take this one. I'll remove this one. Okay. Now this diagram I will draw. First I'm writing this diagram and this diagram inside. This and this I'm going to write inside. Okay. Now just I have drawn this diagram. I have drawn instead of this one. Instead of this one, I'm going to write here. So now I'm getting the answer. Okay, this is also a planner. So which one is a not planner? G1, I can't do it I can't make it as a planner. So this is not a planner. And you can see one more. These are the everything is a PYQ questions. We have to find out which following graph is a planner. You can see here itself. Suppose I will take instead of this line, this one I can make it here this side. Okay, this is possible. Now this is possible or it's possible. Sure, while seeing itself this diagram, it's not at all possible. You can try. Sure, it won't come. So A only is a planner. That's all. Okay, I hope this class is understood. Just we are today we saw only previous year questions and apart from that planner we saw. That's all. Okay, these are the graph based questions. There are many questions we will get graph based questions. Apart from that, we are going to see many questions in the live session. Okay, and if you are interested, sure, if you are interested and you are active in the WhatsApp group, sure, I'll post a very often test also, mark test also. This is up to your interest only. Okay, we will see that one. And thank you all of you. We can see in the next video LPP concept, the optimization techniques we are going to move. Okay, thank you all of you. Thank you once again.